So today we'll be doing the development of reproductive anatomy. So a quick revisit to embryology. Before week 7, we have undifferentiated gonads, the development of our mesonephric ducts and our paramesonephric ducts, also known as our Wolffian ducts, as well as our Mullerian ducts. These, after week 7, develop into our male reproductive system as internal reproductive system and our female reproductive systems, respectively. And therefore, there must be a degeneration or maturation of either the Mullerian or Wolffian ducts in this process. What exactly do these ducts form? Well, the Wolffian ducts form our seminal vesicles, our vas deferens, and epididymis, whilst our Mullerian ducts form our oviducts, our uterus, and cervix. Exactly how this is done? Well, first of all, the concept you got to understand is that if nothing were to occur, every embryo will develop into a female. However, due to the presence of Y chromosome in our genetic males XY, we have the production of the Sry gene, also known as our testes determining gene. This gene acts to cause our undifferentiated gonads to form testes, which then activate somatic support cells of the testes to form Sertoli cells. These Sertoli cells do two actions, one being the production of anti-Mullerian hormone, which acts to cause the degeneration of our Mullerian ducts, which therefore results in there being no female genitalia being present, whilst also stimulating our mesenchymal cells to form Leydig cells. These Leydig cells act to produce testosterone, a key hormone in the production or in the development of the external and internal male genitalia. However, in terms of our external male genitalia, it also requires to be converted into dihydrotestosterone via our 5-alpha reductase enzyme. On the flip side, with genetically female individuals with chromosomes XX, there is no Sry gene, and therefore undifferentiated gonads go the natural course of forming ovaries, and the somatic gonadal support cells become follicle cells or develop into follicle cells. And as this is the case, there is also no Sertoli cells and therefore no anti-Mullerian hormone. Therefore, there is the persistence and development of the Mullerian ducts, whilst there is no testosterone or high levels of testosterone, and therefore the degeneration of our Wolffian ducts, and therefore no development of our male genitalia. Additionally, the follicle cells produce estrogen, which act to develop the external female genitalia. And therefore, the problems that could occur from this are basically whether or not these signal molecules did occur or worked in tandem or against each other, and therefore resulting in different phenotypes being present. Example of this is androgen insensitivity in terms of testosterone. This is the process in which a genetically male patient with XY chromosome has an insensitivity to the testosterone produced by our Leydig cells, and therefore the body takes its natural course and causes it to develop external female genitalia. However, they still have the development of the testes due to the presence of the Sry protein. 5-alpha reductase deficiency is also another condition in which we see there being no conversion of testosterone into dihydrogen testosterone via our 5-alpha reductase enzyme. And as we saw in the previous diagram, that this results in the failure of development of external male genitalia. And therefore, what occurs, you have preserved male internal genitalia as well as sexual characteristics of a male. However, your external genitalia are that of a female. Another condition is congenital adrenal hyperplasia, and this happens in our genetically XX patients. And this is caused by a defect in the 21-hydroxyl enzyme, which is required in the production of our mineralocorticoid and glucocorticoid hormones. Looking at the diagram to the right, we can see if our 21 hydroxyl enzyme is lost, we will have reduced production of aldosterone and cortisol. This then causes a buildup of our progesterone, which then naturally, due to the body's way of maintaining homeostasis, moves on to a process which can break down the progesterone, and that is via the production of the sex hormone testosterone. And as we know, testosterone is key for generating our male internal and external genitalia. And therefore, what occurs is that we have patients who have a spectrum, as you could say, of external and internal genitalia with female internal genitalia, phenotypic characteristics. Another example of a condition that may occur or a problem that may occur is that in a patient with the genotype XY or the sexual chromosome XY, but have no SRY gene being present, and therefore nature will take its natural course, resulting in the development of both female genitalia, internal and external female genitalia. Also, on the flip side, you can also have patients with sex chromosome XX, but with the presence of an SRY gene, and therefore the development of male genitalia as a result of anti-mammalian hormone as well as testosterone due to the pathway shown before. Additionally, malformations can occur due to any of these steps being a bit out of whack and not in line.